Welcome back. This is another problem where you had given a graph. You have to find the largest rank, the rank of two nodes. Here the rank is measured after considering two nodes. Suppose 0 and 1 are considered. The rank of two nodes is the count of links they are sharing. They are not sharing, they are the count of incoming links. So the 0 has 2 and 1 has 3 incoming links, this one and this one, but they have a common link as well. This is their common link. So if this was not common, if there were no common link, then the rank would have been 2 plus 3 which is equal to 5. Since one link is a common, you have to decrement. This is the rank of 0 and 1. So rank of 0 and 1 is 4. For rank of 1 and 2, the number of links incoming to 1 is 3. Number of links incoming to 2 is 1. But they have a common link. So between 1 and 2, it is like 3 plus 1. That is the net link, net incoming link, and minus the shared link. Rank of, we will go in order. 0, 1, let's count 0, 2. 0 and 2. The number of incoming links in the 0 is 2. The number of incoming links in the 2 is 1. And they have no common links. So the rank is 3. Here the rank is 3. Rank of 0 and 3. And 3. The number of incoming links in the 0 is 2. Number of incoming links in the 3 is 2. But there is a common link which is shared between 0 and 3. So you have to decrement that one. So the rank is 3. 0 and 1 is over. 0 and 2 is over. 0 and 3 is over. 1 and 2 is over. Let's compute for 1 and 3. 1 and 3. For 1, the number of incoming links is 3. And for 3, the number of incoming links is 2. But there is a common link between 1 and 3. So you have to reduce 1. So the rank is 3 plus 2, 5. This is 4. 1 and 2 is over. 1 and 3 is over. Now with 3, we have already computed everything because 0, 3 and 3, 0 are same. 3, 1 and 1, 3 are same. Okay, 2, 3, we have internet. We can go with that. 2, 3, 2 have 1 incoming link. 3 have 2 incoming link. So the net answer is 3. So out of all these, you have 4 here, 3 here, 3 here, 3 here, 4 and 3 here. Which one is the maximum of previously? 1. So this is your problem. You have to find the highest rank. So how we will proceed this with a program? So what you can do is like, this will be given as a edge list. Between 0 and 0, 1 will be given as single list. 0, 3 will be given as another element in the list. So whenever you get an edge, increment a invert counter for both ends of the edge. Suppose you are given 0 and 3. So increment a counter for 0, increment a counter for 3. So in that way, you will be receiving the net incoming links at a node. And same time, you create a adjacency list as well. So you can check whether they are sharing any common link or not. If 3 is there in the adjacency list of 0, then you can understand there is a common link between them and you can reduce it. Let's see how the code goes. That will give you more clarity. So you have, these are the roads. Roads means the links. Let's create and you have total n number of nodes. So I create a vector to record the number of incoming links in each of them. And I will create another adjacency list. Yeah. This is like, for that you have to go through the list. Yeah. Coming height of 0. instance. So you have both of them recorded. Now you can update your adjacency list. Here, ID of 0. Insert ID of 1. Yeah, this is the way you record. So you don't have an insert function. Okay, let's set. Yeah, this shall work. Yeah, now you have your adjacency list as initialize your result maximum as 0, maximum rank as 0. Compute the rank, compare it. I less than I plus plus. Compute the rank, and computation will be like max comma. You need both, or j less than j equal to I plus j less j plus. In of I is number of incoming nodes of j minus p of I dot j, then 1, otherwise 0. If there is a link between them, you reduce it by 1 and return that result. Yeah, this is wrong. So we have to correct something. 0, 0, right? 0, 3, 1, 2, 1. Solution is never equal to 1. Yeah, that's correct. It's a small glitch, some referencing problem here. Now it's correct. You are having your rank as 4 has computed over here. Thanks for listening.